Guys, please confirm to me. All of you read my voice on screen. Those who are attending in online, am I audible, guys? Please confirm to me. All of you read my voice on screen. Those who are attending in online, guys, now please confirm to me. All of you read my voice on screen. Those who are attending in online, please confirm to me. Am I audible? Is my voice on screen is clear to all of you guys? Please confirm to me. Yes, clear. All of you read my voice on screen. Those who are attending in online, am I audible? Everybody, guys, now please respond to me. Right. Good evening, guys. And check it what we completed in the last session. So Java history part we completed in the last session. So now today we are going to start the second topic in the introduction part. Right, Java history, the topic we completed, not required to repeat it. Already we understood the total content there. Just it is the meaning of like what there, why and how Java was introduced to the market. Only the topic, that content only I have discussed with you. The second topic in the introduction part is what? Differences between Java and other programming languages. Like mainly I'm going to concentrate on what there, C and C++. So almost all 9 differences here I'm going to cover, but each and every difference is important, very, very important. Try to put more concentration on this content here. Okay. Right. So the very first difference here, what we are going to understand, the very first difference, C and C++ are static programming languages. C and C++ are static programming languages, but Java is a dynamic programming language. Dynamic programming language. This is the very first difference. I want to give some fundamentals here. Now try to understand the fundamentals. So before going to start the discussion of static programming languages and dynamic programming languages, before this discussion, first of all, we have to understand some fundamental concepts. Observe carefully, all of you know. For example, I have written a C program. This is my C program. When I say it's a C program, its extension should be .c, file name .c. This is a C program that I have written. Okay. All right, sir. Now we have written the C program where number of instructions here I have written. When we write the C program, now we have to execute the C program or not? We have to execute the C program. This is like what I'm telling to you, some execution process. Execution. Okay, then who will execute the C programs? Execution is okay, fine, but who will execute the C programs? There is a separate engine or mission to execute the C program. That is what there, C engine. No specific name, no, just general names I'm giving there. C engine. Observe carefully. If I give the C program to the C engine has to execute the program, and the C engine has to generate some outputs from this particular program. From this program, some outputs here we have to get. Output values here we are going to get. This is a process. But understand the point here. Let us talk about the C engine. What the C engine, what it is able to understand. C engine is able to understand and execute the program in a low level program, low level representations. C engine is a machine actually. It is not a human being. C engine is able to understand only what their low level representations, low level program. What is the meaning of this low level program here? What you are going to understand? The total code is going to be provided in the form of like what there zeros and ones. Observe carefully what I am telling there. Something like that. Some mission code, some internal like what there mission code. It is able to understand. Okay, that is the status of the C program. That means C engine. Now coming to the C program. Yeah, see here, example I have taken. It may be C program or it may be a Java program or it may be CPP program, whatever it may be, some program. Right. Now this program is provided by developer. Am I right or not? .c file is prepared by developer. Developer, human being, has written this program. How we wrote this program actually? Developer is able to write this program as per his understanding, as per his understandable level. That means the developer understandable level is what there, that is what their high level representations. That C program, inside the C program, int I is equal to 10, high level representation. For int I is equal to 0, I less than 10, I plus plus, that is what their high level representation. Developer can write the program in what their high level representation. This is like what I'm telling to you, high level representation. Example here I'm telling to you, int I is equal to 10, something else. Here I've written it. This is high level representation. This is what their low level representation. This representation is required to what? C engine. But this representation only developer can write. Developer can write the program in high level. Developer can write the program in only what their high level. But C engine requires the program in what level? Low level. Now observe carefully. In this particular scenario, if I give this high level program to the C engine, is it possible for C engine to execute that high level program directly? Think and give the answer. Is it possible for C engine to run our high level program? No, C engine can understand only what their low level program. But we provided what program there? High level program. Then how is it possible to execute our program in this particular context here? Right. Now I'm going to give some clarity. Now observe carefully. So in this particular scenario, developer is unable to write the program in low level. C engine is unable to execute the program directly in high level. So exactly in this particular situation, to execute our program, where we need some translation. What is required there? Some translation is required. What type of translation is required here? Here we need a translation to convert the program from high level representation to low level representation. That conversion here we require to convert the program from high level representation to low level representation. There we require some translation mechanism. The translation could be done by a translator. The translation could be done by whom there? Translator. Now observe carefully. Alright, sir. Now here to perform this translation, we are going to use a translator separately. Here we are going to use a separate translator. Observe carefully. This is like for their translation. Alright, sir. This is like for their translation. Understand it clearly. Alright, sir. Then what is going to be happen when we provide this C program to this translator? This translator will convert the program from high level representation to low level representation. That low level representation is going to be provided in the form of like what there some other file. The low level representation is going to be provided in the form of some other file. What data is going to be available here? We can understand it clearly. Some representation here we are going to provide. Like this, here we are going to have some representation. Observe carefully. This is low level representation. This is low level representation. Now, whenever we are getting the low level representation, that low level representation is going to be provided in the form of .exe file. In the form of what file is there? .exe file. Whenever we are getting the .exe file, if we give the .exe file to the C engine, now directly C engine will take that low level representation, it can execute that program, and finally it is able to provide some output. Finally our program is going to be executed, and here we are able to get some output. All of you observe carefully. In this total process, a translator here we are going to use to translate the program from high level representation to low level representation, or a translation mechanism we are using to translate the program from high level representation to low level representation. The translation mechanism is called compilation, and the translator is called as what? There, compiler. Everybody understand my point clearly? Compilation or compiler? Directly I'm asking this question to you, try to answer for it. What exactly the purpose of the compilation? What is the requirement of the compilation? The very first point is what? There, to translate the program from high level representation to low level representation, we have to use compilation. What is the requirement of converting program from high level to low level? What is the requirement to convert program from high level to low level? Why? Because C engine is able to understand only low level program. C engine is able to execute only low level program. So we have to supply low level program to the C engine. Because of that reason, first we will write the program in high level, that is in our understandable level. Later on we are going to convert that program from high level to low level. Later on we will provide that low level program to what? There, C engine. Now C engine will execute it. C engine is able to provide some output. Because of this particular reason, we have to convert the program from high level to low level. To convert the program from high level to low level, there we have to use what? There, compilation. Point number one, here we have to understand. All right, sir. Now, compilation main responsibility is what? There, compilation main responsibility is what? There, translate from high level representation to low level representation. That is point number one. Observe carefully. Next, one more point here I'm telling you. Who is writing this program actually? Developer, right? Programmer or developer. Yeah, definitely, developer is a human being, right? Then what is the fundamental right for a human being? Fundamental right for a human being. Taking food and sleeping, no? Not like that. The fundamental right for a human being is what? There, committing mistakes, doing mistakes. Definitely. Then everybody, even if we call James Gosling to write Java program, definitely able to have some mistakes. Everybody will have mistakes. But in my point of view, my philosophy is what? There, in your practice, if you are getting more number of errors, feel happy for it. Don't feel bad about your programming. Feel happy for it. If you are getting more number of errors, you are going to learn more subject. And first attempt itself, if you are getting output, no, don't feel happy for it. The simple example I am telling that. If you are getting more number of errors, no, don't panic by seeing that all the errors, no, but sit there, try to resolve one by one, one by one, one by one, try to analyze why these errors are coming there. At the end, you are going to get very good knowledge. So whenever we are getting more number of errors, no, feel happy. Why? Because we are going to learn more subject. Understand it now? Right, sir. Now in the same way, the point here, what I am telling to you, developers are writing the program. Definitely, developers may have some mistakes, may have, not confirmed, may have mistakes. Okay. Without checking errors, without checking mistakes, trying to execute the program is a big crime. Without checking errors, trying to execute the program is not suggestible, is a big crime. So because of that reason, what we have to do before going to execute the program, first we have to check whether our program is having errors or not. First cross check it. First we have to check that process, whether we are having any error or not in our program. If no error is available, then send that program for what their execution. If you have any error, then directly display that error message to the user. Then we are able to get it. We are able to correct that program. Again, we are going to execute our program there after checking that errors. So here, what is required now? Before executing our program, first we need a checking process of errors or not. Whether our program is provided as per Java rules and regulations or not. Our program is provided as per C rules and regulations or not. The checking process is required or not. That checking process is also be done by whom? Compilation or compiler. That is the second responsibility of the compiler. What is the second responsibility of the compiler? No, right? Compiler will check errors. Error checking. What is the next responsibility? Error checking is the next responsibility of the compilation. That's enough. Now I'm asking this question to you. Now try to answer for it. What exactly the purpose of the compilation in a programming language is? No, because of two reasons. First one is what there, translating our program from high level to low level, and the second one is what there, error checking. Because of these two reasons only, we are performing what there, compilation. Got it or not? Nice. Right, sir. Now let's move on to the point here. Observe carefully. One more point here I'm telling to you, understand it. For example, if I provide a variable into a is equal to 10, semicolon, for example, into a is equal to 10, for example, here if I provide no, what is going to be happen actually? When we compile or when we execute this statement, what is going to be happen internally? Right, what is going to be happen internally? First, a variable will have some memory, a block of memory will be provided for a variable. How much memory for integer? No, that depends on the programming language. If it is a C programming language, 2 bytes of memory. If it is Java programming language, 4 bytes of memory. Depends on programming language, that memory allocation is going to be happen. About this memory allocation, I will give some conclusions in the future. But first of all, understand it. A is a variable. For that variable, some block of memory will be created. In that block of memory, the value 10 is going to be stored. The value 10 is going to be stored in the block of memory. First of all, tell me, int a is equal to 10 in the sense, for the data type, on the base of the data type int, a block of memory will be created or not? So memory allocation will be provided for the variables or not on the base of the data types. Now memory allocation, the word is what there, memory allocation for the data. Here data is 10 now, variable is, the data is what there, 10 now, the data name is what there, a, data is what there, 10 now, its name is what there, a. Observe carefully. For that a, memory allocation will be provided or not? For the variables, memory allocation will be provided or not? All of you understand my point clearly? Everybody put more concentration. Almost I'm coming to the ending point, that means close to the our actual conclusion. Observe carefully. If the memory allocation is provided for the primitive data, what data? Primitive data, byte, short, int, long, float, double, boolean character, like this. All these are what they're primitive data. If the memory allocation is provided for the primitive data at a compilation time, at what time there? Compilation time, then that memory allocation is called as static memory allocation. Everybody put more concentration here. If the memory allocation is going on for the data at a compilation time, then that memory allocation is called as what there? Static memory allocation. Nice. Next one is after that. Similarly, the point here I'm telling to you, another point here I'm telling to you, if the memory allocation is going on for the data at a runtime, of course, this is compilation time, no? Similarly, here we are going to provide some other time, that is like what there, runtime, or we may call it as what there, execution time. Runtime or execution time, all these are same names for this particular execution process, no? Execution time. The time when we execute the program, that is what there, execution time, or maybe runtime. Understand it clearly. If you provide memory allocation for the data at a runtime, if the memory allocation is going on for the data at a runtime, not at compilation time, then that type of memory allocation is called as what there, dynamic memory allocation. What type of memory allocation it is? No, dynamic memory allocation. Guys, all of you now tell me, What is static memory allocation? What is dynamic memory allocation? If the memory allocation is going on at what time? Compilation time. Then it is what there? Static memory allocation. If the memory allocation is provided at runtime, then that memory allocation is what there? Dynamic memory allocation. All of you are getting clarity up to now? Clear? Now I'm giving conclusion. Observe carefully. If any programming language is following static memory allocation, then that programming language is static programming language. If any programming language is following dynamic memory allocation, then that programming language is what there? Dynamic programming language. No second thought. Conclusion is very clear. Actually, our point is what there. Now tell me, C and C++ are what? Static programming languages. Java is what there? Dynamic programming language. Now tell me the definitions. You know, the point is what there? If any programming language follows static memory allocation, then that programming language is called as static programming language. Now I'm giving clarity. Examples are like what there? C and C++. Why? Because in C and C++, memory will be allocated for the data at a compilation time only. Right, sir. Note I'm giving clarity to you. Now try to understand that note here. What is that point here? Observe carefully. Right. Now, if the memory allocation is provided for the data at a compilation time, if the memory allocation is provided for the data at compilation time, then that memory allocation is called static memory allocation. Right. Now, in a C and C++ applications, memory will be allocated for the data at a compilation time only. You may get one question immediately. In the case of C and C++, sir, in C and C++, memory will be allocated for the data at compilation time. That is a standard point, no doubt for that. But by using malloc and cloc functions, we can allocate the memory at runtime also. In the case of C and C++. But how can we say that C is following only static memory allocation? There we can get like what? Dynamic memory allocation also. Then how can you say that C is a static programming language? They may have this type of question also. Yes, sir. All of you are getting it or not? Sir, actually we don't know about C and C++. Why you are asking these questions now? Information. If you are getting this type of question again, then try to remember this. In C and C++, cloc, like malloc functions are available. By using these functions, we can get memory at what time? No, runtime. Okay, remember cloc, malloc, like these two functions now. But the point is what there? I'm giving this total definition and everything on the base of the default memory allocation, not like explicit memory allocation. CLAC is what their request for the C engine to allocate memory. This is explicit request, explicit memory allocation, not default memory allocation. But what is the meaning of default memory allocation? If I provide into A is equal 10, where at what time memory will be allocated for A? Is that at compilation time? Static memory allocation. If it is at runtime, then dynamic memory allocation. So providing memory for the primitive data types is a default memory allocation. Providing memory for the primitive data types is what their default memory allocation. Understand my point clearly? So because of that reason, in C and C++, by default, memory will be allocated for the data at what time? Compilation time. That is the reason why C and C++ are following static memory allocation, and C and C++ are what their static programming languages. Leave this point here. This is completed. Next one is after that. What about this dynamic programming language? Now tell me exactly the same definition here I'm telling to you. Same concepts here I'm going to provide, but we have to go for some changes here. Now observe the changes now. First of all, the point is what there? If any programming language follows what? Dynamic memory allocation, then the programming language is what there? Dynamic programming language. Examples are like what there? Not only Java, .NET, Python, and so on. So many programming languages are available. Leave it. Next one is what there? Then after this, if the memory allocation is provided for the data at runtime, not at what their compilation time. Runtime in the sense what their execution time here. Then that memory allocation is called as what their dynamic memory allocation. Right, sir. In Java applications, mainly here we are focusing on Java. That's why I'm going to use only the Java. In Java applications, memory will be allocated for the data at what time, you know, at a runtime. At a runtime. That's it. Right, sir. Now the total content, the required information I completed here. The remaining part is what there. I have to provide this diagram. Now try to understand the diagram. Here I'm providing the diagrammatic representation so that we are able to get some clarity. Our first difference is completed in the differences between C, Java and other programming languages. All of you are getting clarity? All of you are getting clarity in it? Can I move forward? All right. The second one is somewhat difficult, at the same time somewhat newer one, but try to put more concentration. It's not simple to understand, but I'll make it simple, but try to put more focus skill. Right. Now the second difference. Observe carefully. Preprocessor. Preprocessor is required in a C and a C++, but a preprocessor is not required in Java. Does not required in Java. Preprocessor is required in C and C++, but preprocessor is not required in Java. This is the second point. All right, sir. Your attention is very, very important. Now try to put more concentration. Before going to understand preprocessor is required or preprocessor is not required in C, C++, Java. Before that, first of all, tell me what is preprocessor, what is the job of the preprocessor, okay, and what is the location of the preprocessor in programming languages, that we have to understand first. After that, we are going to understand whether preprocessor is required or not required. Later on, we are going to understand. Okay, all right, sir. Now observe carefully. What is the location of the preprocessor? Everybody, put more concentration. Preprocessor point here I'm telling you. Now understand it clearly. First of all, I'm going to write a C program. This is my C program. When I said the C program, there we can understand it is like what there. That extension is what there. Dot C. Extension is what there. Dot C. Fine. When we prepare the C program, then we have to go for compilation. There we have to go for what there. Compilation. Okay. When we compile the program, there we are able to get already what files here we are able to get in the case of C and C++ .exe files. Of course, .obj files, .exe files are different files here we are getting. One small difference I'm telling there in between Java and C, C++. In C, C++, .exe, .obj, .asl, like different files are coming after compilation. But in the case of Java, after compilation, only one type of file, that is what their .class file. No confusion, straightforward, only .class files, that's it. Leave it. Whenever we are getting .exe files, no, we need to go for execution. I want to execute the program. So for that, here we are going to provide execution process. C engine, here we are going to use to execute the program there. Execution. All right, after executing the program, there definitely we are able to get what there, some outputs. Then we are going to use what their outputs. This is the total content of like what there, our program. Right, sir. C program, compilation, .exe file, execution, and some output here we are getting. Now I want to elaborate the compilation process. I want to elaborate the compilation process. In general, most of the people are thinking compilation is going to be performed by using only compiler. The compiler is a component which performs the compilation. People are thinking like that, but it is not like that. Compilation is a work performed by 4 missions. The total compilation is performed by 4 missions. The total 4 missions worth is what their compilation. Let us understand it. What are the 4 missions here we are going to use? The first one is, the very first mission is what there, understand it clearly. Preprocessor. The first one is what there, preprocessor. Next one is what there, compiler. Next one is assembler. Then after this, loader, link, editor. These four missions work or worth is what their compilation. It's not like single mission work. Four missions together they have to work. Then only total compilation is going to be performed. Right, sir. Just 1 minute. Right, sir. By this almost all I'm giving the clarity, the location of the preprocessor we are getting. By seeing up to this diagram here, we understood that the location of the preprocessor. Tell me, what is the location of the preprocessor, sir? The location of the preprocessor is the first phase of the compilation or not? First phase in the compilation is what their pre-processing phase only. First phase in the compilation is what their pre-processing only. Okay, fine. Now my required point I'm getting there. But further, still, I want to elaborate this compiler structure, internal structure. In the future, I required this one. That's why here itself, I want to elaborate the total compiler internal structure. Let me provide that next level also. After that, I want to stop it. I'll come back to our actual point here. Observe carefully. What you are able to have the compiler internal structure. The compiler internal structure contains nearly 6 phases. Compiler internal structure contains nearly what phases there? 6 phases. What are the various phases there? First one is lexical analysis. Next one is syntax analysis. Next one is semantic analysis. Semantic analysis. After that, intermediate code generation. Intermediate code generation. After this, code optimization. After this code optimization, code generation. Right, sir. These are all the phases which are available inside the compiler. Almost all 6 number of phases are available inside the compiler. Observe carefully. All right, sir. Now this is the lexical analysis and syntax analysis, semantic analysis, and intermediate code generation, code optimization, and code generation. Of course, along with all these 6 number of phases, few more data structures are available. Symbol table, error handler tables like this. Few more data structures are available, but we don't require up to that level. It is moving on to like what there compiler construction, compiler design part here, but it's not required for us now. Up to this part is sufficient here, right? Compiler internal structure here I'm providing, try to understand it clearly. Now the point is what? I don't require all these phases immediately. I don't require all the phases immediately. Why? Because my required point is what there preprocessor only. That preprocessor related content here already given. But the point is what there in the future I'm able to use what there that compiler internal structure. Because of that reason here itself I'm giving clarity. Okay. Right, sir. Now it is completed. I want to take this diagram. I want to keep the diagram in the document. Okay, fine. Leave this. In the future, I'm going to use it. Now coming to the point here. What is the location of the preprocessor? Preprocessor is the first phase of the compilation. First phase of the compilation. This is the point here. We have to understand. Next one is, what is the job of the preprocessor? What is the role of the preprocessor? Now I'm going to give some story. Now try to understand it clearly now. Listen carefully. In C and C++ applications or in C and C++ programming languages, the complete predefined library was provided in the form of header files. Am I right or not? In C and C++, the complete predefined library was provided in the form of what there? Header files. Now tell me some examples for these header files actually. stdio.h. Next one is what there? conio.h. Then after that, math.h, and so on and so on. So many things are available. Okay, these are sufficient here. Math.h, like this here we are having there. All of you understand it now. In C and C++, the complete predefined library was provided in the form of header files. stdio.h, con.h, math.h, and so on. That's okay, fine. Listen carefully. In a C and C++ applications, if we want to use predefined library in a C and C++ applications, if we want to use predefined library, then we have to include the required header files in the C and C++ applications. For this, we have to use, to include header files, we have to use hash include statements. Yes, sir. What statements here we are using there? Hash include statements here we are using. In a C and C++ applications, if we want to use predefined library, then we have to include the required header files in the C and C++ applications. For this, we have to use what there? Hash include statements. All of you understand it clearly. All right, sir. Now, example here I'm telling to you, now observe carefully. Hash include stdio.h. Hash include conio.h. All right, sir. Next one is what there? After this, hash include math.h. Like this here, we are able to write what there? Header files. Right. 2 minutes of time. Put more concentration. I prepare a C program. I prepared a C file, C program, .c file. Inside the C program, I have written all the hash include statements. Inside the C program, I have written what their hash include statements like this. I compiled my C program. When I compile my C program, preprocessor will recognize all the hash include statements. Who will recognize all the hash include statements? No, preprocessor will recognize all the hash include statements. Preprocessor will take the provided header files names. Preprocessor will take the provided header files names. Preprocessor will go to the C and C++ softwares. Already we have installed them into our system. After that only we've written this program. We are writing this program. When we compile this program, preprocessor will recognize hash include statements. Preprocessor will take all the header files names. Preprocessor will go to C and C++ softwares where preprocessor will search whether these header files are available or not available. Preprocessor will check whether these header files are existed or not existed. If these header files are not existed, then preprocessor will raise some error. The compilation process will raise some error. Some errors it able to provide. If these header files are available in the C++ softwares, preprocessor will take the header files. Preprocessor will load that header files content to the memory. Preprocessor will load that predefined library to the memory at the time of compilation only. Loading predefined library at compilation time is called as static loading. Loading predefined library at compilation time is called as what there? Static loading. C and C++ is following static loading. C and C++ is following what loading there? Static loading. Understand my point clearly? And hash include statement is following what there? Static loading. Preprocessor is performing what loading there? Static loading. That's it. Now this is the job of what there? Preprocessor. Right, sir. Now tell me, what is the job of the preprocessor here? Now tell me, no. Right, sir. Observe carefully. If we compile C and C++ programs, then the preprocessor will perform the following actions. Now tell me, sir, one by one, we have to tell me what exactly the actions that preprocessor is able to perform there. First one is what there? Preprocessor will recognize all the header files, recognize all the hash include statements. Hash include statements and hash include statements. Next one is preprocessor will take all the provided header files names from the hash include statements. Okay, preprocessor will check whether the provided header files are existed or not in the C and in the C and C++ softwares. Understand my point clearly? Alright, sir. Now, preprocessor will check where the provided header files exist or not in the C and C++ softwares. Observe carefully. If the provided header files names, if the provided header files do not exist in a C and C++ softwares, then the preprocessor will raise an error. What is the error? No, the error description is what there. The specified header files are not existed in our C software or C++ softwares. Like this here, we are able to get some errors now. Right, sir. If the provided header files exist, if the provided header files exist in a C and C++ softwares, then the preprocessor, what it will do there? Preprocessor will load the provided header files content to the memory. C and C++. That means preprocessor will load the provided header files content to the memory. Understand the point clearly? My required content is completed here. Alright, note I am telling to you, observe carefully. Loading predefined library at a compilation time is called static loading. Loading predefined library at compilation time is called as what there? Loading the predefined library at compilation time is called as what there? Static loading. Now coming to the conclusion now. Why preprocessor is required in C and C++? We understood what is the location of the preprocessor. We understood what is the job of the preprocessor. Now the point is what? Why preprocessor is required in C and C++? That we have to understand now. Now I'm giving clarity. Observe carefully. Preprocessor is required. Preprocessor is required in a C and C++. Why? Because in a C and C++ or else maybe preprocessor is required in C and C++ in order to recognize hash include statements and in order to load the header files content to the memory. In order to load the header files content to the memory. That's it. Now this is the requirement of like what their preprocessor. Point is very clear. Observe carefully. What is the actual title is what there? Preprocessor is required in what there? C and C++, but preprocessor is not required in what there? Java. That's the point here. First of all, what I've given there? Location of the preprocessor I've given. Preprocessor is the first phase of the compilation. Then what is the job of the preprocessor? There I've given the information. In a C and C++, the complete predefined library was provided in the form of what files? No, header files. Examples are what there? Yesterday.h, conio.h, math.h. In a C and C++ applications, if you want to use predefined library, then we have to include the required header files in the C and C++ applications. For this, we have to use what there? Hash include statements. What are the examples for these hash include statements? No, hash include yesterday.h, hash include conio.h, or hash include math.h. If we compile C and C++ programs, then the preprocessor will perform the following actions. What is the job of the preprocessor? Now tell me. Preprocessor will recognize all the hash include statements. Preprocessor will take all the header files names from hash include statements. Preprocessor will search for them in the C and C++ softwares. If they are not available, preprocessor will raise an error. If they are available, preprocessor will load the header files content to the memory. Loading predefined library at a compilation time is called as what there? Static loading. Preprocessor is required in C and C++ in order to recognize hash include statements and in order to load the header files content to the memory. Because of this particular reason, preprocessor is required. Is that all of you are getting clarity? The related diagram here I have given there. Now that we can understand clearly. Yes, sir. Can I move forward? No response. All of you are following the content now? Let just 2 minutes of time. If you give that 5 minutes of time, I'll complete it. After that, you can ask the same question now. Okay, right, fine. I think you are a bit hurry about the technology. Wait, few minutes of time. All right, sir. Now let's move on to the point here. So about C and C++ here we understood. Clear about what there? C and C++, how the preprocessor is required. That point here we understood. Now the point is what? The next point is what there? Preprocessor is not required in Java. Preprocessor is not required in Java. Now let us understand the point here. So before going to start my Java related content here, this is a diagram I have given with respect to C and C++. Now I want to convert this diagram to what there? Java. Let's see this. What changes here we required now? What changes here we required? Can observe carefully. First of all, I want to remove the name like what there? Dot C. In place of the dot C, here what we are able to get there? Dot Java. Java programs. That extension is what there? Dot Java. After compilation of this Java program, what files here we are able to get now? Dot .exe. There automatically we are able to get what there? Dot class files. Nice. Execution and output here, it's okay, fine. Officially we are confirming that in Java preprocessor is not required. Am I right or not? So just I want to strike off this. In Java which is not available, preprocessor is not available. Why it is not required, I will explain to you. No need to worry for it. But the diagrammatic point of view, not required to provide what their preprocessor. Remaining part of the program is as it is, that we can identify. All right. Now this is about like what their Java related diagram. All right. So now here itself I'm going to give the diagram here. Observe carefully. Okay, fine. Now coming to the Java. Why preprocessor is not required inside the Java? Observe carefully. In Java, all of you observe carefully. In Java, the complete predefined library was provided. The complete predefined library was provided in the form of classes and interfaces inside the packages. Please all of you understand it now. Don't have any question like what is a class, what is interface. No, immediately just understand it. They're like some programming elements. Libraries available with these concepts only. They're going to be available in the form of the packages. If you ask a question what is a package, package is what their collection of classes and interfaces. Understand the point here? Fine. All right, sir, it's okay, fine. Examples here I'm telling to you. What are the various examples for the packages? No, java.io, java.util, for example. Next one is java.sql. Like this, number of packages are available. So many packages are available. Just example 3 only here I have written there. Java.io, java.util, java.sql. Got. Observe carefully. In Java applications, to use predefined library, in C and C++, to use a header files, we have used a hash include statement. Am I right or not? In C and C++, to use a header files, we have used what there? Hash include statement. Similarly, in Java applications, to use predefined library, we have to include packages. We have to include packages in the Java programs or Java applications. Here to include packages inside the Java programs, we have to use what statements there? Import statements. Understand my point here? In the case of Java, in Java applications, to use predefined library, we have to include packages in the Java applications. Right, sir. We have to use packages. We have to include packages. Okay, here to include packages inside the Java programs, we have to use what statements there? No, import statements. Okay, fine. Now let us move on to the examples here for this import statements. Now, what are the various examples here? Observe carefully. Import java.io.star. What is the meaning of this star? Actually, package is a collection of classes and interfaces. My intention is I want to get all classes and interfaces from java.io package to represent all members from java.io. For that purpose, we are using what there? Star. That's the main intention, we can understand. Next one is import java.util.star. Next one is import java.sql.star. Right, sir. Now these are about like what their import statements. Clear? All of you understand it now clearly? Next, observe carefully. I prepared a Java program. In my Java program, I have written all these import statements. Now I'm compiling my Java program. When I compile my Java program, remember carefully, when I compile my Java program, preprocessor is not available in Java. Understand it now. Compiler will recognize all the import statements. Compiler will take the provided packages names. Compiler will go to the Java software. Inside the Java software, compiler will check whether these provided packages are available or not available. If the specified packages are not available in Java software, compiler will raise an error like package XYZ does not exist. Package java.io does not exist. Package java.util does not exist. Package java.sql does not exist. Like this, we are able to get some error message if the provided packages are not available in Java software. If the provided packages are available inside the Java software, then compiler will not raise any error. Compiler will not raise any error. At the same time, compiler will not load any package content to the memory. Compiler will not load any package content to the memory. Observe carefully. Compiler is not responsible for loading library to the memory. Compiler is responsible for checking whether that libraries are existed or not existed. If they're not existed, error will come. If they're existed, no error will come. At the same time, compiler will not load any predefined library to the memory. This is job of the compiler. If the compiler is not responsible for loading predefined library, then who is responsible for loading predefined library to the memory? Who will take the responsibility of loading predefined library to the memory? If we come for this point now, in Java, JVM will take the responsibility of loading predefined library. Why? Because Java is a dynamic programming language. In Java, everything is going on at what time here? Runtime maximum. Observe carefully. In Java, when we execute Java program, JVM will load the required classes and interfaces to the memory from the packages. That's it. JVM will load the required classes and interfaces to the memory at runtime of the application, not at compilation of time of the application. Understand my point here now? So because of that reason, because of this total view, Java doesn't require preprocessor. Why? Because recognize the predefined library, loading that predefined library to the memory, that could be done by compiler and as well as what their JVM. Both are performing that activity. Then what is the need of this preprocessor inside the Java? So because of that reason, Java doesn't allow preprocessor component inside the Java programming language. Right, sir. Try to understand my point here. Once again, I'm explaining this Java part here. Try to understand it now. C and C++ part is namesake only we have to understand. But our required topic is what there Java. In Java, what is going to be happen? Right, sir. In Java, if you prepare a Java program with the import statements, if we compile Java program, then the compiler will perform some activities. What activities the compiler will perform there? Compiler will recognize all the import statements. Compiler will take all the provided package names. Compiler will check whether these packages are available inside the Java software or not. If these packages are available inside the Java software, compiler will not raise any error. If these packages are not available inside the Java software, then compiler will raise an error. Observe carefully. Okay. At the same time, compiler is not responsible for loading any predefined library to the memory. In Java applications, when we execute the program, JVM will load the required classes and interfaces to the memory from the packages as per the requirement. Without having any requirement, even JVM also not loading any classes or interfaces to the memory. If it is required, then only it will load that class or interface to the memory. So in Java, predefined library will be loaded at what time here? Runtime of the application, not at compilation time now. So Java is following dynamic loading. Java is following what their dynamic loading. Import statements are supporting what their dynamic loading. JVM is performing what their dynamic loading. But in the case of C and C++, what type of loading is going on there? Static loading is going on. But in the case of Java, what type of loading is going on there? Dynamic loading is going on. Now tell me, is that preprocessor supporting the dynamic loading? Is that preprocessor supporting dynamic loading? Definitely it is not supporting here. Because of that reason, Java doesn't require what there? Preprocessor. And moreover, what exactly the work that could be done by preprocessor? That would be done by compiler and JVM inside the Java software. Because of that reason, we don't require what there? Preprocessor kind of component inside the Java. Yes, sir. Got it or not? All right, sir. Now, let's move on to the point here. What I'm telling you now. Clear? Are you getting clarity on this point now? Right, sir. Let me go for this total conclusion here. Now, observe carefully. If we compile Java program, if we compile Java program, then the compiler will perform the following actions. If we compile the Java program, then the compiler will perform the following actions. What actions the compiler is able to perform there? The first one is what there? Compiler will recognize the import statements. Compiler will take all the provided package names. Right, sir. Compiler will recognize all the import statement. Compiler will take all the provided package names. Compiler will check whether the provided packages exist or not in the Java software. Right, sir. Now the next point is, if the provided packages are not existed, if the provided packages do not exist in the Java software, then the compiler will raise an error. That error message is not required here at this moment, no, but understand the point clearly. Error, okay, fine. If the provided packages are existed in the Java software, if the provided packages are existed in the Java software, then the compiler will not raise any error. But at the same time, at the same time, at the same time, the compiler, at the same time, the compiler will not load any package content to the memory. That's okay, fine. This is completed. After completion of this particular point here, the point is what there? Execution here now. When we execute Java application, JVM will perform the following actions. What JVM will perform there now? Observe carefully. When we execute Java program, JVM will perform the following actions. First one is JVM. Observe carefully. I think all these points are not required here. Right. When we execute Java applications, JVM will load the required classes and interfaces to the memory at a runtime. At a runtime. Loading predefined library to the memory at a runtime. Loading predefined library to the memory at runtime is called dynamic loading. What it is known? Dynamic loading. Right, sir. When we execute Java program, when we execute the Java application, JVM will load the required class and interfaces to the memory at runtime. Loading predefined library to the memory at runtime is called what there? Dynamic loading. Right, sir. All of you are getting my point clearly. Right, sir. Now Java. Now coming to the conclusion here, I'm telling to you. Already we are aware about the conclusion. Right, sir. Now in Java, preprocessor is not required. Why? Because in Java, observe carefully. In Java, then what I'm telling there, preprocessor is not required. Why? Because in Java, hash includes statements are not available. Hash include statements in Java. Hash include statements and header files are not existed, not available. In Java, the complete predefined library is available in the form of packages. In the form of what their packages. All right, sir. 1 minute. Let me clear about it now. In Java applications, or in Java, preprocessor is not required. Why? Because in Java, hash include statements and header files are not available. In Java, complete predefined library is available in the form of packages, comma, to include these packages, import statements are available. So because of that reason, preprocessor is not required in the case of Java. That is required in the case of only what there? C and C++. Got it clearly? Right, sir. Now let's move to the next point here. If we understand this one here, this particular point here, now I want to ask one important interview question now at fresher level. Definitely this question here we are able to get. What is that question here we are able to get there? What are the differences between, observe carefully, what are the differences between hash include statements and import statements? What are the differences between hash include statements and import statements? The simple answers only here we are going to understand. Observe carefully. Our noun answers only here I'm giving. As per our today's discussion only I'm asking this question. Try to answer, understand it clearly. The very first one. Hash include statements exist in C and C++. Whereas import statements exist in Java. First point. Point number two, what they are able to include. What hash include statement is including, what import statements are including. Observe carefully. Hash include statements are able to include the predefined library. Hash include statements are able to include the predefined library which are available in the which are available in the header files, But whereas import statements are able to include the predefined library which are available in the packages. Right, sir. Observe carefully what hash include statements are including and what import statements are including. That points here, if you observe this, hash include statements are able to include the predefined library which are available in the header files. Import statements are able to include the predefined library which are available in the form of what their packages. That we have to understand. It's okay, fine. Next, point number 3. Who are going to evaluate? Who is evaluating hash include statement? Who is evaluating import statement? If you understand it, hash include statements are evaluated by the preprocessor. Evaluated by the preprocessor. But in Java, import statements are evaluated by both the compiler and JVM. Both are going to evaluate the import statements. Why? Because compiler has to check whether the packages are available or not. For that, it must evaluate import statement. JVM has to load the packages content to the memory or not. So it must evaluate what their import statements. Import statements are evaluated by both compiler and JVM. But the hash include statements are evaluated by whom? Preprocessor only. Right, sir. What type of loading is supported by hash include statement? What type of loading is provided by import statements actually? Hash include statements supports static loading. Hash include statements are supporting what there? Static loading. Next one is what there? Import statements support dynamic loading. Import statements are supporting what there? Dynamic loading. All right. Next, another point here. I'm asking one question. Try to answer for it. Is the syntax is possible in C? Is this syntax is possible in C? Is it possible to load more than one header file by using single hash include statement? Come on, sir. Is it possible to load more than one header file by using single hash include statement? No, it is not possible. So one hash include statement is able to include one header file. Per header file, one hash include statement. That's the equation. All right. Now the point is like what there, what I am telling to you. Okay, now hash include yesterday what dot catch. Okay, hash include conio dot catch. Hash include math dot catch. That means single hash include statement is able to load only one header file. If you want to include more than one header file, if you want to include more than one header files, we have to use more than one hash include statement. More than one hash include statement. Example here I've given. Now try to understand it clearly. Right. Now the point is what? Example here I've given there. Next one is what there. In Java applications, by using single import statement, we are able to include more than one class or more than one interface from the same package by using star notation. Understand this point here? In Java applications, by using single import statement, we are able to include more than one class or more than one interface of the same package from the same package by using star notation. What is that example here? I'm telling to you, import java.io.star. When I provide this star, automatically all classes and interface of the java.io package are coming or not? All classes and interfaces here we are able to get. But if we use like what there hash include something as star, if we provide, no, it will not work. For every header file we have to write separately. But here if we provide star, no, automatically all classes and interface of that particular package is available or not. So because of that reason, one statement is sufficient to get more than one class or more than one interface. But here the equality we have to maintain. Header file is equal to class. Header file is equal to interface. That we have to understand. But in Java, extra is what their packages. Packages are able to include what their all the classes and interfaces. Okay. Forget about all the points. Totally, we understood the differences between hash include statements and import statement. What is the first difference here? Now tell me. Hash include statements exist in C and C++, but import statements exist in what there? Java. Hash include statements are able to include the predefined library which are available in header files. Import statements are able to include the predefined library which are available in the packages. Hash include statements are evaluated by the preprocessor, whereas import statements are evaluated by both compiler and JVM. Hash include statements are supporting static loading, but import statements are supporting what their dynamic loading. Single hash include statement is able to load only one header file. If you want to include more than one header file, then we have to use more than one hash include statement. Multiple hash include statements here we have written. But in Java applications, to include by using single import statement, we are able to include more than one class or more than one interface from the same package by using what notation there? Star notation. Import java.io.star is the best example, where star is representing all classes and interfaces from the same package. Right, sir. Now related diagram also here I provided here. Now try to understand it. Now this is the totally the second difference here what we are getting about like what there the differences between Java and the second difference here we completed. And the third difference is what there, observe carefully. C and C++ are platform dependent programming languages, but Java is a platform independent programming language. That's now this is also be one of the important topic and the differences between Java and others. Some internals I'm going to be covered there. So without fail, try to understand this content now. Okay. Right, sir. This topic I will start on tomorrow. Tomorrow we are going to understand this total content. Okay. Right, sir. That's all for today. Then tomorrow we'll see the remaining part. Thank you. Thanks a lot. Then guys, those are attending in online, then listen carefully. Links are going to be changed, guys. Then please try to register for the courses. Then within 1 or 2 days of time, things are going to be changed. For the registered members, you are able to get that link details through mail. All right. For the unregistered members, you are unable to get it now, but try to register immediately. Thank you. Thanks a lot. Right. Thank you guys. Thanks a lot. Thanks a lot. Yeah, notes link already are given, guys. Then you can check this. At the starting point of the page, I have given already that link details now. Just take this is the link details now. There we are able to get what there daily classroom notes. Just take this link. Okay. అంటే నేను ఒకటి ఇదంతా దుర్గాసాఫ్ట్ పెట్టిన కోర్సెస్ ఇండివిజువల్ అంతే. ఇది బయట స్టాండర్డైజేషన్ ఏం కాదు ఇవి. స్టాండర్డైజేషన్ అంటే ఫుల్ స్టాక్ జావానే. కంపెనీ పాయింట్ ఆఫ్ వ్యూ ఇవేమి ఉండవు. కంపెనీస్ పాయింట్ ఆఫ్ వ్యూ ఫుల్ స్టాక్ జావానే ఉంటుంది. అర్థం చేసుకోండి. ఇది స్టూడెంట్స్ ఫ్లెక్సిబిలిటీ కోసమే ఉన్నాం అని పెట్టినవి ఇవన్నీ కూడా. యాక్చువల్ కంపెనీ పాయింట్ ఆఫ్ వ్యూ జావా అంటేనే ఫుల్ స్టాక్ జావా. ఈ పార్ట్ మొత్తం అవసరం అవుతుంది. ఇంక లేదంటే కొంతమంది ఏంటంటే టెస్టింగ్ టూల్స్కి వెళ్తూ ఉంటారు. వాళ్ళు కోర్ ఒక్కటే కావాలి. అట్లాంటి వాటి కోసం ఇండివిజువల్ బ్యాచెస్ పెట్టినాం అనమాట. జనరల్గా జావా అంటేనే ఫుల్ స్టాక్ జావా. అట్లా అంటే ఒకటి ఇప్పుడు నేనేమంటానంటే ప్రజెంట్ మార్కెట్ ఎట్లా ఉందంటే కంప్లీట్గా వెళ్దాం. ఇప్పుడు ప్రజెంట్ సిచ్యువేషన్ అంతా కూడా ఎట్లా ఉందంటే ఒక డెవలపర్ని తీసుకుంటే ఆ డెవలపర్ అన్నిట్లో ఇన్వాల్వ్ అవ్వాలి. ఫ్రంట్ ఎండ్ డెవలప్మెంట్ కానీ, మిడిల్ వేర్ కానీ, లేదా బ్యాక్ ఎండ్ డెవలప్మెంట్ కానీ, మొత్తం ఏ టు జెడ్ రైట్ ఫ్రమ్ స్టార్టింగ్ పాయింట్ ఆఫ్ ది ప్రాజెక్ట్ ద ఎండింగ్ పాయింట్ ఆఫ్ ది ప్రాజెక్ట్ ఆ రిసోర్స్ని యూటిలైజ్ చేసుకుంటారు. వాళ్ళనే ఫుల్ స్టాక్ జావా డెవలపర్ అంటారు. ఇప్పుడు కంపెనీ వాళ్ళ అప్రోచ్ మొత్తం అదే ఎట్లా తీసుకున్నా సరే. అందుకని చెప్పి ఫుల్ స్టాక్ జావానే రైట్ ఆప్షన్ ప్రజెంట్ మార్కెట్లో. ట్రెండింగ్ అంతా అదే. ఒక సింపుల్ ఎగ్జాంపుల్ చెప్తాను చూడు. జాబ్ పోర్టల్ ఓపెన్ చేయదని జాబ్ పోర్టల్ దానిలో ఒకసారి చెక్ చేయి. ఏం అడుగుతున్నారు, ఏ డెవలపర్స్ని ఎక్కువ కంపెనీస్ అడుగుతున్నాయి చెక్ చేయండి అని మీకు క్లారిటీ వస్తుంది. ఫుల్ స్టాక్ జావానే మొత్తం. Thank you, Varun. Thanks a lot. And Pawan, Indra, recorded class link, guys. Guys, our admin people will share that link details to you, that recorded video details to you. I think already our admin people are sharing some Excel sheet with you with the links now. That Excel sheet access was provided to everybody to share the links, to get the links. Directly you can get it now. Then in this number, we can talk with our admin people there that they are able to provide the required details to you regarding that. Okay. Yeah. Thank you, guys. Thanks a lot. Fine. Anything else, guys? Shall we meet on tomorrow? Right. Thank you. Thanks a lot. Yeah. Good night, guys. Good night to all of you. Thanks a lot. We'll meet on tomorrow.